Hello everyone, welcome to JEE, Vedanta Telugu JEE. Sorry, not Telugu. I got habituated to say that. Okay, I have to change my style. It's been a while. So welcome to JEE English. Okay. Am I audible? Can you see me? Can you hear me? If yes, please say clear. If yes, please say clear. If you can see me and if you can hear me, please say clear. What happened to Shreyas sir? We will be sharing the lectures from now on. So sir is going to get busy in Maharashtra channel. So we are going to share the load. I will be taking some classes here. He will also be taking some classes here. And we both are going to be into, I'll be into Telugu channel and he is going to be into Marathi channel. And I think it is going to get launched soon, or it already got launched. I don't know exactly. Okay. Yes, we got a clear cut message that yes, it is clear. Then fine, we will go ahead. So as you are a new crowd, I just want to introduce myself. Okay. One second, I was just looking at how many are there. Okay. No, I don't think there is any lag. Obviously, if you talk about the live, there will be some 20 to 30 seconds of gap. Or might be in some situations, it might be 1 minute also. But yes. Okay, a brief introduction about me for all those people who are new, who don't know me. See, here you can see a title. I call myself as your Big B and your physics coach. Actually, it should be physics coach, but it turns out to be lengthy, right? So it's just coach. Why I call myself to be Big B? Your big brother. The Big B is nothing but big brother. Why I call myself to be a big brother? See, when I was in my 11th and 12th, I was not having any clue about what was the JEE, how to prepare. So all those difficulties, whatever I have gone through, I used to feel that if there is someone in my family who is going to be an elder brother to me, who has gone through, who could have guided me properly, I could have done it better. So I was missing on that big brother. If he was there, if he is going to be there, they would have led me in a proper way, right? But unfortunately, I didn't have. But for you people, I am someone who has gone through whatever you people are going through now. So like a big brother, I'm going to hold your hand and I'm going to guide you how to deal with all the things you are going to come across. So that's why I call myself as your Big B. Then why do I call myself as the coach? Till now, physics would have been playing football with you, right? So I will coach you in such a way that you will play football with physics. So that's the reason why I am going to call myself as Big B as well as your coach. And if you look at my brief background, I have been teaching from past 9 years, 2015. I am 2015 passed out. I have done BTech from IIT Dhanbad, you can see that, right? So I have 9+ years of experience, and entire 9 years of experience I was teaching in English only. I was based out in Bangalore, right? So Bangalore, I was teaching in English. It's, I think from past 2 to 3 months or something like that, I'm teaching in Telugu also. I take classes in Vedanta Telugu JEE also, right? Okay. Varun Velvak. What happened, man? He's saying that I am depressed. Why are you depressed? Hi sir, I was following you in Vedanta Telugu. Nice, but the problem here is going to be I'll be talking in English because this is a channel which is going to cater to the whole country, right? So nice if there are people from Telugu also. Andarki emantaru namaskaram. Hi sir, I was following you. Okay, fine. That's a brief introduction about me. So as I said, I have gone through what you are going through, what you are going to go through. I have gone through that. Whatever the examinations you are going to be writing, I have already given that. So what kind of pressure is going to be there, how to approach, all those things will be taken care. You don't need to worry at all. Okay, then let us just move as it is displayed. We are going to talk about oscillations, and in that oscillations one specific case will be there, or one specific motion will be there called as SHM, simple harmonic motion, right? We are going to completely deal with that. We will completely, like, we will do literally post-mortem of that, the whole SHM. I think it is going to be in 2 or maximum 3 sessions. I'll just be done with SHM, and that too in deep. Whatever the conceptual thing I have to give you, I'll give you. And one more thing, we have an animation also ready. I'll use that animation, right? I have kept it over here. I'll use that animation mostly in next 10 minutes. So first we will talk about different types of motions. If we talk about different types of motions, there will be specifically, let's take 2 categories. One which are going to be so random. There is no fixed thing. There is no fixed time after which they are going to repeat. They might not repeat also. But there will be some set of motions which are going to be repeating. In those also, there will be some types of motions which are going to repeat after regular intervals of time. So we are going to talk about those motions which are going to repeat after regular intervals of time, and a few more conditions are going to get added when we are going to go deep. So the first thing is, we are going to talk about periodic motion. So what is this periodic motion? The only condition that has to be satisfied to be called as a periodic motion is motion should repeat after regular intervals of time. After regular intervals of time, the motion has to repeat. That's the only condition. If it is repeating, then we call it as periodic motion. For example, moon around earth, or minutes hand in the clock, or seconds hand in the clock, or hours hand in the clock, or earth rotating, or earth's motion around sun. All these things, they repeat after regular intervals of time, so we call them as periodic. Now in these periodic motions, if one more condition is satisfied, we call them to be oscillatory. So what is oscillatory? So what is going to be called as oscillatory motion? So basically, repeats after, first condition that has to be satisfied is it repeats after regular intervals of time. This is the first condition. It repeats after regular intervals of time. And the second condition is going to be, it should be a to and fro. It should be a to and fro motion about a point. So that point about which the motion is going to be to and fro is going to be called as mean position. Is going to be called as mean position. And one more thing is that whenever I am going to talk about oscillatory, there will be 2 categories of oscillatory motions. One is going to be linear oscillations and other is going to be angular oscillations. That also I'll just give you. What is meant by linear oscillation? So I'll just give you an example. You just take a spring and block, you pull the block and you leave it. You just pull it and you leave it, then it is going to be oscillating like this. So the oscillation is along a straight line. Then when the oscillations are going to be along a straight line, we call it as linear SHM. And then when I am going to be talking about angular SHMs, sorry, not SHM, right now don't call them as SHM. By mistake I have used the word SHM. We are in oscillatory. Okay, fine. Anything which is going to be to and fro and which is repeating the motion after regular intervals of time, when both the conditions are met, we call that motion as oscillatory. Okay. So what is angular oscillatory motion? For example, you just take a pendulum, right? You deviate it by some angle, You leave it, then it goes to this side, then comes back and goes. So like that, it will be doing motion like this. So these are going to be called as angular oscillatory motions. That's it. And as I said, the point about which they are going to do to and fro motion is going to be called as mean position. And one more thing, before I go forward, can I call all oscillatory as periodic? Yes, for sure you can call. To be called as a periodic motion, only one condition has to be satisfied, that is the motion has to repeat after regular intervals of time. And when I say oscillatory, is it repeating after regular intervals of time? Yes. So for sure all oscillatory are periodic. Now, can we say all periodic as oscillatory? So when we say periodic, it repeats after regular intervals of time, but we don't know whether it is a to and fro motion or not. So for oscillatory, two conditions have to be satisfied. There are no prerequisites required for this session. Psycho is edits. So there are no prerequisites. You don't need to worry, right? I'll just take care. Whatever I am going to be doing, minimal basics of physics which you know up to your 10th standard or slight extension, very small extensions are needed. That's it. I'll make sure that all the lectures are going to be going in the same way. Even if you don't know anything, even if you know that F is equal to M into A, that's more than enough. I'll be able to help you out. Hey, Madhan, one more Madhan has come. Where are you from, man? Mr. Madhan. Yes, Emmanuel, this is from basics. This lecture is going to be from basics. Slowly I'll dig deep and I am going to be showing you some animations also, which is going to be to the pro level. Yep, to the pro level. Okay. So someone is saying teaching is awesome. I do. To be frank, I'm a bit nervous. After a long time, I'm speaking in English. Being honest. After a long time in the sense, I started teaching from July 10th in Telugu channel. So I was talking in Telugu from long time. So might be unknowingly sometimes some Telugu words might kick in, but don't take it bad. Okay, fine. Now, I was talking about mean position, right? See, as I said, there will definitely be a point about which they do to and fro motion. That point is going to be called as mean position. The block goes this side and the block goes this side. How? It goes like this. About this point it goes to the right side and to the left side, to the right side, to the left side. So that position is going to be called as mean position. And what are those things? See, the mean position is the point where the net force on the particle will be 0. If it is linear SHM, net force on the particle is going to be 0 at the mean position. That's how you are going to be identifying the mean position. So if the net force is going to be 0, the particle wants to be at that location or not. So every time when you are going to be displacing the particle from the mean position, let's take this point to be the mean position, and you have a block, you are displacing it from the mean position by some x. If this body is going to be performing oscillatory motion, then this block, if you pull it and leave, it should come back. And it should be doing like this, these kind of oscillations. For you to visualize, you better think of spring and block. You pull it and you leave it, then it is going to be what? Performing oscillatory motion. So, if you are going to be displacing the block from the mean position by x, there should be some force which should try to bring it back. Only then it will come back. Only then it will be performing oscillations. Right? So there should be a force which will be trying to bring it back. And when the block is going to go on to this side, obviously when it is on to this side, definitely then also there should be a force which should try to bring it back. Only then oscillation is going to be possible, otherwise it is not. And one more thing is that if x is onto the positive side, force should be towards the negative side. And if displacement displacement from the mean position is to the left side, then the force is to the right side. That's a clear indication that f and x should have that opposite sign kind of thingy. So this is giving me a hint that this force should be proportional to minus x power n. Sir, you might have a doubt, sir, how you got to know that it should be proportional to x? If you are going to be pulling it more distance, there should be more force acting on it. Sir, how do you claim that? Man, when I am going to be talking about oscillatory motions, they should repeat after regular intervals of time. So if I pull it by more distance, if the force is more, only then they can cover more distance in the same amount of time. If you have to cover more distance, it should gain more speed. Then for more speed, it should have more acceleration. For more acceleration, it should have more force. That's it. Okay. Fine. That's how I got to know that force should be definitely proportional to x. More displacement, strong is the force to bring it back. Okay. Now look, what should be that n? That n should be odd number. Why it has to be odd number? For example, if n is going to be even number, for example, let's take n is equal to 2, then f is going to be proportional to minus x square. So when I am going to talk about the block or the particle being onto the negative side, so when I am going to put that minus x square, which will result in what? Force being to the negative side. So force acting to the right is positive and force acting to the left is negative is what I am going to take. Just keep in mind, whatever is going to be to the right side is positive, whatever is to the left side is going to be negative. Look, when the displacement is to the right side, I have taken plus x. When the displacement is to the left side, I have taken minus x. So now you tell me, if the force is negative, that's an indication that if I have a force like this acting, then the force on the block is to this side. So will it ever come back? Our aim is what? We need an oscillatory motion. That means the particle should be oscillating like this. So when it is onto this side, there should be a force which should try to bring it back. Instead, if the force is proportional to minus x square, what it is trying to do? It is trying to take it away. So it is never going to come back. It is never going to come back. Now, if n is going to be an odd number, if n is going to be 3, now you see, if the force is proportional to this, and when I am going to talk about a block which is going to be to the negative x side, now put it over here, this f is going to be proportional to minus of minus x cube. So minus x cube will give you minus out, and you already have one minus, so you are going to get f to be what? Positive. So indicating that the force is going to be acting onto this side. That's why for sure the force which is trying to bring back the particle in oscillatory motion should be proportional to minus x to the power n, and where n is an odd number, for sure it should be an odd number. Okay. Now we have realized a few things. If the force acting is proportional to minus x power n, and when n is an odd number, it's an oscillatory motion. We got that. Now I want to talk about a very basic oscillatory motion, that is case 1. Very basic oscillatory motion, that is case 1. So case 1, can you tell me what is the first odd number? Can you tell me what is the first odd number? The first odd number is going to be n is equal to 1, right? So I'll just talk about force being proportional to minus x to the power 1. Now that proportionality, whatever is there, I'll replace it with a constant. It is some random constant. Please don't take it as spring constant. For example, if you are going to look at this situation, yes, you can clearly see that the spring is the one which is going to try to bring back the block. But can you see any spring over here? No. So not every time there will be a spring and block only. In many oscillatory motions there won't be spring at all. So that's why my request to you is that when I am replacing the proportionality constant, I am replacing it with k. But the thing is, just keep in mind that k is a constant but not a spring constant. It can be any constant. Okay, fine. Now we can write force as what? Mass times acceleration. And acceleration can be written as what? D square x by dt square. So now d square x by dt square plus k by m into x is equal to what? 0. Do you know how to solve this differential equation? Nah. Will you be taught in 11th and 12th, even in mathematics, double differential equation is out of syllabus for you. Double differential equation is out of syllabus for you. Then how to do it? No way. There is one way, but I am skipping that. I am just going to give you a bit of math here. Whenever you come across any differential equation which is going to look like this, the general solution for this one, is going to be x is equal to some a sine omega t plus phi, or x is equal to a cos omega t plus phi dash. This should be there on your fingertips. You have to mug it up. Or there is one more way. That is, see, once you are going to get the acceleration as minus k by m into x, you can write acceleration as v dv by dx. So from there you are going to get vx relation, and then you can write v as dx by dt, get xt relation, which is going to have a bit of integration. I don't want you to go through that, rather you go in this way, it's fine. Right? Now some people will get it out. Sir, should we take sine or should we take cos? You can take whatever you want. Man, here you can see phi and phi dash. I have not written phi and phi, I have written phi and phi dash. Whether you take this as your solution of this equation or whether you take this as the solution of this equation, it doesn't matter. Ultimately both of them will give you same answer. For example, the conditions that are mentioned in the question gave us phi to be pi by 2. Then it will be a sine omega t plus pi by 2, which is going to be what? Cos omega t. So if you start taking the solution as this and when you do it, then you will get phi as 0. So if you take sine, you get phi as pi by 2. If you take cos, you get phi dash as 0. So ultimately both of them will give you what? This will give you a sine omega t plus pi by 2, which will be a cos omega t. And this one, a cos omega t plus 0, which is a cos omega t. See, whether you take this or whether you take this, don't worry, you will get same answer. Now, if we compare these two, who is playing the role of omega square? Omega square role is played by k by m. So omega square role is played by k by m. What is the omega? Under root of k by m. This is going to be very, very, very helpful. In future it is going to be very, very helpful. Okay. Now, We found out a solution, and that solution is what? X is equal to, for example, I am just taking only this to save time. We found that the displacement from mean position, X is what? Displacement from the mean position is a function of, as a function of time. And that relation, if you are going to look at, that relation is what? It's sine. And how a sine graph is going to look like? How a sine graph is going to look like? Like this. How a cos graph is going to look like? How a cos graph is going to look like? Can I say like this? How sine cube is going to look like? Sine cube also it's going to be in the same way. How cos cube is going to be? Similar thing. So whenever you see a shape like this, we call them as harmonic functions, right? Out of sine cube, even if you take sine to the power 5, sine to the power 7, you take whatever you want. Whatever might be the power of sine, the graph will be same. The graph will be same. So all these trigonometric things are called as harmonic functions. They are called as harmonic functions. Out of all these things, can you tell me what is the simplest harmonic one? Is sine cube simplest or sine is simplest? I think sine is the simplest form. So when you look at the oscillatory motion, when force is proportional to minus x to the power 1, the solution of it came out to be what? Simple harmonic. It's a simple harmonic function. So as the solution is interesting, this particular motion, which is oscillatory, will also be called as from now on this oscillatory motion will also be called as simple harmonic motion. That's it. So simple harmonic motion is nothing but a special case of oscillatory motion. What is that special case? The force that is going to be acting should be proportional to minus x. If the force is going to be proportional to minus x, then the solution is coming out to be a simple harmonic function. So that oscillatory motion from now on will be called as SHM. So if the force is going to be proportional to minus x cube, will this be called as SHM? No. This is oscillatory, but not SHM. If force is going to be proportional to minus x, it's oscillatory, and we will also call it as SHM. So by now everyone have understood when we are going to call it as SHM. To call it as an SHM, force should be proportional to minus x. If force is proportional to minus x, displacement from the mean position is a simple harmonic function. That's why we call it as simple harmonic motion. Okay. Now we understood what is it. That is, what is SHM? Why it is called as SHM? Now let us understand the complete solution whatever we have got. We got the solution to be x is equal to a sine omega t plus phi. What is x? Displacement from mean position. Now I will define what is y, what is a. Look, when we talk about mean position, x is displacement from mean position. Now, can you tell me what can be the maximum value the x can have? See, a is a constant. What is changing with the time? Sine is changing with the time. Why? As time changes, omega t changes. That means this value will be changing. If this value is going to be changing, sine value will be changing. So if you want x to be maximum, sine should be maximum. What is the maximum value of sine? 1. So you tell me, whatever the particle is executing SHM, maximum can go till where? Can go to this side. How much? Plus a. Next, what is the least value this x can get? When the sine is going to be lowest. What is the lowest of the sine? -1. So on to the other side, how much maximum it can go? It's -1. Okay, let me draw that. So whatever I am talking about, whatever the particle I will be talking about which is executing SHM will always be confined to this region. It will be continuously moving like this, that's it. It won't be able to come out of it. It will be only over here. What is that a called as then? A is the maximum distance it can move from the mean position on either sides. Distance. So a can never be negative and we call it as amplitude. So a is called amplitude. A is called amplitude, and what it is called? It's the max distance it can move from the mean position on either sides. That's it. Okay, now look, we know what is a, and what is omega, what is phi, and what is this whole thing called as? Man, first I'll talk about this whole thing. For example, you are going to buy a house. When you are going to go and ask the person, whoever is there at the construction site, you are going to ask a question, at what phase the construction is going on? When you say at what phase the construction is going on, immediately they will reply back saying that, okay, interior work is going on or the foundation work is going on. So when you use the word at what phase the construction is going on, exactly what is the stage of construction. Now you tell me, if you know this value, do you know the position of the particle? Yes. For example, if omega t plus phi is 30 degrees, then what is sine 30? Sine 30 is 1 by 2. So the moment you are going to put 1 by 2, x is a by 2. Did you know the location of the particle? Yes. So if omega t plus phi is going to be 60 degrees, then a sine 60. Sine 60 is what? Root 3a by 2. Then x is going to be what? Root 3a by 2. So do you know the position of it? Yes. So what this thing is giving you? This is giving you information about the exact location of the particle. That's why that whole thing is going to be called as phase. So if you look at the phase, as time changes, phase is changing. But this is the one which is not changing. So as time changes, omega t changes. As time changes, omega t changes, but not phi. So in this phase, this phi is a constant. That's why this will be called as phase constant. I'm just building the concepts. Slowly I'll go a bit faster. Right? Just a second. Oh, nice. Okay. I just looked at how many live students are there. Because I wanted to show you some animations which are waiting. So if I have to show you animations, I can't see the live crowd. Fine. So this phi is called phase constant. Now finally I have to give name to this one. Now you tell me, whatever the omega t is going to be there, that omega t is inside the argument of sine. Argument is nothing but those brackets. So ultimately this whole thing should be what? 30 degrees, 60 degrees, 90 degrees. So basically this whole thing is going to be what? Angle. That means ultimately omega t should give you angle, right? So omega t should give you angle. Now that angle, I'll take t. Now 1 by t can be called as what? 1 by t is going to be what? Frequency. So the name that is given for omega is angular frequency. The name that is given for omega is angular frequency. Now we know everything, man. In x is equal to a sin omega t plus phi, we know everything. X is displacement from the mean position. A is amplitude. What does amplitude give you? Amplitude gives you information about from the mean position maximum how much it goes. To the right side or to the left side. And what the omega is going to give you? Omega is called as angular frequency. And what the phi is going to give you? It is going to be called as phase constant, or when you put t as 0, what is the phase? Phi. T0 means we take T0 as initial conditions, right? So phi sometimes will also be called as initial phase. At t is equal to 0, what will be the phase? The phase is going to be omega into 0 plus phi. So what will be the phase at time t is equal to 0? It's phi. So whatever is going to be there at time t is equal to 0, we call them as initial. So the initial phase is phi. Initial phase is phi. So now we know everything, right? And I said we are talking about those motions which are going to repeat after regular intervals of time. That means they repeat after a certain amount of time. After how much time they repeat? That's called time period. And what is that time period? Time period is represented with a letter capital P. What is it? It's the minimum time. It's the minimum time after which motion repeats. Okay, so nice, good. Let us find the time period then. X is equal to a sine omega t plus phi, right? After how much time? Again it is going to be at the same location doing the same motion again. So that new time is going to be, obviously, already t time is elapsed. From there, if capital T time is elapsed, that's the time after which again it repeats, right? So the new time is small t plus capital T. So when you do that, you get, now you tell me, compare these two has to be same. If those two has to be same, what should be the minimum value of this one? I think it should be 2 pi. So now you tell me, what is the time period? 2 pi by omega. Those who are having a doubt that omega t, how it is 2 pi? 2 pi is the period of sine function. What is period? After every 2 pi it repeats itself. Sine. After 4 pi also it repeats. After 6 pi also it repeats. But minimum after every 2 pi it repeats. So if the omega t is going to be 2 pi, then you can keep this as 2 pi plus omega t plus phi, which is nothing but this. So the whole motion is again repeating. If omega t is 2 pi, so the time period of SHM is 2 pi by omega. Okay. We are done with all the basic things. Now I'll show you some animations. You can see over here, we have a particle. This particle is going to be executing SHM, right? So how the position of it is going to be changing, how the velocity of it is going to be there, how the acceleration of it is going to be there, how the force of it is going to be there. I will not show you the energy ones. Here I have taken few things. Mass is 5 kg, the spring constant is 20, and the gravitational acceleration is 9.8. Amplitude I have taken 0.1 meters, which is nothing but 10 centimeters. Let me just start it. How it is going to look like. You just see, isn't it performing oscillations? Yes, it is doing oscillations. And can you see something over here? Okay, I'll reset it. So at time t is equal to 0, what is the displacement from the mean position? This much. That value is 0.1. Why? I have taken the amplitude as 0.1 and it is starting when I am going to unfreeze the time, that is when I am going to press the start button, it is starting here. It is starting here. So you can see your displacement is going to be what? 0.1. Now look, I'll put it in slow motion. I'll take it. As this is going down, obviously displacement from mean position is going down, and when it is here, see the displacement 0. When it is going down, displacement is negative. Let it reach its maximum. Yes, it has reached its maximum. Yes, maximum. Now again when it is going to go up, displacement is still negative. It is going to be 0, and here also it is what? 0. So basically this graph is giving you displacement of the particle from the mean position, or you can also call it as position of the particle with respect to the mean position. That's it. Look, I'll remove it. Now, it is very clear that when the particle is moving, it is not having constant velocity, man. You can see here it is coming to rest. Here it is at this location also, it is at rest. So every time when it is changing its direction, it is slowing down, coming to rest and changing its direction. That means the velocity is not constant, right? So let us analyze what is happening to velocity. Oh, this is moving too fast. I'll just keep it in slow motion. Have you observed the size of the arrow became 0? Now the size of the arrow is increasing. That means the size of the arrow indicates over here the velocity, and the velocity is maximum when it is at the mean position. When it is crossing the mean position, the size of the arrow is decreasing. That means the velocity of the particle is decreasing. Now look, size of the arrow becomes 0 because the particle has come to rest. There is no velocity. Again the size of the arrow is increasing. And when it is at the mean position, arrow size is maximum. Again the size of the arrow is decreasing. And it became what? 0 because it has come to rest. So what we realized is that velocity is 0 at the extremes and is maximum when it is crossing the mean position. It should make sense. Why? Whenever you are going to be talking about mean position, what is the force over there? At mean position, what should be the net force? 0. If the net force is going to be 0, acceleration is going to be 0. When acceleration is going to be 0, rate of change of velocity is 0. If rate of change of velocity is 0, that's the point where velocity is either maximum or minimum. Right? Okay. Let us just stop that. Let us look at how the acceleration is going to be. Look at the acceleration, man. Obviously, the acceleration has to become 0 at the mean position. Why? At mean position, there is no force. If there is no force, acceleration is going to be 0. And you can see the size of the arrow has reached maximum when the particle is at the extreme. Yes, if you talk about the restoring force is minus kx. So if x is more in magnitude, f is also more in magnitude. You look here also. X is more in magnitude, so f is also more in magnitude. If f is more in magnitude, acceleration is also more in magnitude because f is equal to m into a. Clear? In whichever direction acceleration will be there, in that direction only force will be there. Or in whichever direction force will be there, in that direction only acceleration will be there. Let's see how the force is going to be. Can you see the force? Size of the arrow is increasing. Now it is maximum. Again, when it starts moving down, the force is decreasing, And what is the size of the arrow? 0 when it is crossing the mean position. And can you see how the direction of the arrow is changing? So if it is down, there is a force asking it to go up because mean position is up. When it is up, there is a force asking it to come down because the mean position is going to be down. So always the force will get developed in such a way that it will be asking it to go towards the mean position, but never it will be able to stop at the mean position. Reason being, it accelerated this whole journey. So by the time it comes over here, it has velocity, so it overshoots. When it overshoots, again force will slow it down, is asking it to bring it up. As a result, it will be oscillating. Is that clear, everyone? Is that clear? Just please respond. Okay, super. We'll go back. So whatever we have learned, let us do that. Whatever we have learned, let us see it mathematically. Nilin Paul, clear. Good, man. I need active participation of the students. Okay, fine. Now we have x. X is what? Let us say some a sine omega t plus phi. How do we get the velocity, or how do we get the speed? The rate at which the position is going to change is velocity or not? So that velocity, I'll take it as dx by dt. That means I have to differentiate. A is a constant. What is differentiation of sine? It's cos. And we have omega t plus phi rather than t. So what is omega t differentiation? It's omega. Deepa Sarvanan, sir, is this 11th or 12th? SHM is 11th, amma. SHM is 11th. Hi Sanju. Hi. Sarvanan. Are you from Tamil Nadu, Deepa? Sanju, where are you from? Yes, I'm just interested in knowing where are you people from. So all those who are in live, can you just type in the states you are from? I'm new to this channel, right? So I just want to see crowd belongs to which state. Vijay is saying, sir, we used to watch in Vedanta Telugu JEE. Okay. Sanju, AP, Andhra Pradesh, huh? Lakshmi, AP, Nelinpal, AP, man. Then you people would be following me in what we call in Vedanta Telugu also. Okay, we have Tamil, we have Kannada, like Karnataka from TN, Tamil, Tamil. Super. So it's basically a common crowd. Basically, mostly it is a south crowd, I think. Telugu Ammai living in Tamil Nadu, Shushma. Lucky Charan, Telangana, Deepa Saravanan, TN, Tangapandi, TN. Okay, fine. Let's continue. I hope everyone understood the differentiation of this. So what will be the V, man? It is A cos omega t plus phi. And one small request. I will not be plotting the graphs between x and t, v and t. Plotting the graphs between x and t, v and t is waste of time. Barely they are going to be giving you questions on that. I am from Guntur, man. Mystery boy. Okay, fine. We got V and T relation. Is there any way for us to relate V and X? I have a slight doubt. I have cos here and I can see sine over there. So this cos, can I write it as 1 minus sine square? And that sine can be written as what? X by a. 1 minus x by a square. And if you do the LCM and when you simplify it, you get this. True, man. They were bang. Those simulations were bang. Bang on this thing. If you remember, at x is equal to plus or minus a, what's the speed? It's omega under root of a square minus a square, which is going to be what? 0. That means at the extremes, the particle is at rest. That's what the simulation has shown us. Okay. Now, when x is going to be 0, look man, omega is constant. It's root k by m. Already I proved it. Amplitude, okay, constant. So what will happen? Position of the particle will be changing with respect to time. So this is a constant, this is a constant. If you want maximum of this, then you should subtract least. What is the least value of x square? As it is a square, it can't be negative. X square can't be negative. So if you have a square, the least value of that square can be 0. So at x is equal to 0, you get v to be what? Omega under root of a square, and that v is the maximum speed. So what is the maximum speed? The maximum speed is a omega. I can't even say it. How important is this? It's very, very, very important. If you can mug it up, it's fine. My native is from Nellore, Mr. Curious Cortex. Kondapuram, it's a place called as Kondapuram, near Kavali. So there are people asking me, do you like Telugu or do you like English? I like both, man. Adiksha, sir, are you going to finish the whole chapter today? No, Amma. I have divided it into 2 parts. Today we will be talking about the kinetics of SHM. Tomorrow we will be talking about exclusively only time periods. How to calculate the time periods of SHM. And for JEE mains, kinetics of SHM is important. And for JEE advanced, time period of SHM is important. Okay, now look, we got this. Sometimes they are going to ask you, what is the graph between V and X? What is the graph between V and X? That's one big challenge majority of the students are going to have. I will give you one trick of how to identify. Look, V square can be written as, see, I am doing squaring over here. Just a second. So V square minus by omega square is this. So now I will write it like this. X square plus V square by omega square is a square. So I can write x square by capital A square plus V square by a omega square is equal to 1. When you look at this, it's very hard for you to process. Your brain generally doesn't process any of those equations which are going to be in the form of xv, xt, something and all. Your brain processes stuff faster if it is going to be x and y. So if I am going to say y is equal to mx plus c, y is equal to mx plus c means immediately everyone are like, sir, it's a straight line. Y is equal to x square, sir, it's a parabola. x square by a square plus y square by b square is equal to 1. Sir, ellipse. It's ellipse only. So basically how you are going to be identifying, I'll just give you, see this is x, let us say this to be v, whatever is plotted on y axis, that in the equation you change it to y. What I am trying to tell you is x square by a square, whatever is put on y axis, you change it to y. Now you people can clearly see that it's an ellipse. Semi-major axis A, semi-minor axis A omega. Okay, so what do you get here? You get a shape like this, where this is going to be capital A and this is going to be A omega. So the graph between V and X is going to be an ellipse. Okay, super, good. We have Shreyas sir also in the chat. Yeah, hi man. Okay, fine. We got V and X relation. Now, let us go for A also. We got velocity. And in the simulation, whatever I have shown to you, I hope you people remember the simulation. In the simulation, whatever I have shown to you, I have shown you velocity, I have shown you acceleration also. Right? Now let us find how the acceleration is going to be. So how do we get the acceleration? Acceleration is going to be what? Obviously dv by dt. For your kind information, we just got the v to be what? A omega cos omega t plus phi. Now we have to differentiate this fellow. It's okay, Ash. Concentrate, you'll learn. You will learn something extra. Okay, let us differentiate. A omega is a constant. So A omega. What is differentiation of cos? Minus sine omega t plus phi. Obviously again we have to differentiate omega t plus phi. Omega t differentiation will be omega. So you are getting the acceleration as minus a omega square sine omega t plus phi. Man, I'll write it properly. I'll just take omega square or minus omega square, and this, if you look at, isn't it x? Isn't this what we have started with? A straightforward relation, man. Acceleration is minus omega square x. Very, very important. What is the maximum magnitude of acceleration you can get? See, what is the maximum magnitude of x? A. So the maximum magnitude of acceleration executing, maximum acceleration of the particle executing SHM is going to be capital A omega square. So two important things which you should keep in mind is that the maximum speed a particle executing SHM is going to be A omega, and the maximum acceleration the particle executing SHM is going to have is A omega square. Okay, now we got this, but yes, we need the graph, right? We need to do the graph. So now look, acceleration, and this is x. When you look at this, every one of you are going to be like, what might be the graph? Because as I said, your brain doesn't process a and x. Your brain always processes y and x very fast. So what is the trick which I have given to you? I said whatever is going to be drawn on the y-axis, that you have to put as y. So you put a as y, then you get y is equal to minus omega square into x. So this is of what form? Y is equal to mx form. That means it's a straight line. And what is the slope? Minus omega square. Straight line passing through origin, And what is the slope of this straight line? It is going to be minus omega square. So now we have a detailed view of what will be the acceleration, what will be the velocity, all those things. We have a clear-cut idea. Let us see where JEE mains is going to focus more. Ding. Wow, perfect, man. I have chosen right amount of slides. Let's do. A particle of mass 0.5 kg executes simple harmonic motion under force F is equal to minus 50x. The time period of oscillation is x by 35. The value of x is, man, this is 2024 9th April evening shift question. Okay. So, if you are going to be talking about the force, it should be compared with minus kx. And what is given, man? What is given over here? The force is given as minus 50x. So, who is playing the role of k here? The k value over here is 50. And for your kind information, if you remember, I have already given in the beginning of this lecture that the omega is root k by m. I have to go a lot, but still I'll go. Look, mathematical comparison when I have done, omega square is k by m, omega is root k by m, very, very, very helpful. Fast. Okay. Now we need time period. I also proved that the time period of SHM is 2 pi by omega. So time period is going to be 2 pi under root of m by k. Okay. What's the mass? Half. What's the k? 50. Let's put that. 2 pi root m. M is half kg by 50. So it is going to be 2 pi by 10, which is going to be pi by 5. Compare. We got the answer to be pi by 5. So pi by 5, we should compare it with what? X by 35. And pi is what? 22 by 7. Which is x by 35. 35 gets cancelled out. X is going to be how much? 22. That's it. The answer for this question is 22. As I said, JEE mains will be bothered more about these kinetics. Okay. One more. I have around 7-8 questions, man. Come on, fast. Come on, fast. A particle is doing simple harmonic motion of amplitude 0.06 meter and time period of 3.14 second. So the amplitude is given as 0.06, time period is 3.14, basically it is nothing but pi, the maximum velocity of the particle. Man, see, time period is what? 2 pi by omega. Why I am writing it as 2 pi by omega, I'll explain, but we can cancel these things. From here, omega is going to be what? 2. So, if you talk about the maximum speed the particle is going to have, it is a omega. What is the a value? 0.06 into 2. So, you are going to get 0.12 meters per second. But they are asking centimeters per second. So, I can write it as 12 centimeters per second. So, the answer over here is 12. These are the kind of questions they are asking recent days. Displacement of a particle executing SHM is given by x is equal to 10 sin omega t plus pi by 3. The time period of motion is 3.14. Velocity of the particle at t is equal to 0. When you put t is equal to 0, you get 10 sin omega into 0 plus pi by 3, which is sin 60. Sin 60 is going to be what? Sin 60 is root 3 by 2. Okay. So you get x to be what? 5 root 3, sir. But they are not expecting you to calculate the maximum speed. They are expecting you to calculate the speed at that moment. So what is the speed at that moment? Omega under root of a square minus x square. So omega, they haven't given, but they gave the time period. So time period is given as how much? 3.14, and the time period can be written as what? 2 pi by omega, and 3.14 is pi. So omega is how much? 2. So do you know omega? Yep, I know 2. What's the amplitude, sir? 10, sir. So 10 square minus what is the x value? 5 root 3 square. So 200 minus 75. So you get 10. So what's your answer? Your answer is going to be 10. Super, Nilin. Yes, we can also get the same thing by differentiating. We can also get the same thing by differentiating. If you differentiate, you are going to get velocity. True. Good, Yash. Now look at this. A particle executes simple harmonic motion with an amplitude of 4 centimeter. At the mean position, velocity of the particle is 10 centimeters per second. Okay, that means they gave the maximum. They didn't say the maximum to be 10. They indirectly gave that it is maximum. Distance of the particle from the mean position when its speed becomes 5. Man, look. They gave amplitude to be 4. So amplitude is given as 4 centimeters. And a omega is given as 10 centimeters. The omega is going to be 10 by 4, which is going to be 2.5. That's the first thing. Now they are asking you distance of the particle from the mean position. They are asking x. They gave v. Good. V is omega under root of a square minus x square. What is the v? 5. What is the omega? 2.5. What is the amplitude? 4. What is x? That's what we have to calculate. So 2.5, 2 times. So 2 is equal to under root of 4 square minus x square. So you have 16 minus x square to be equal to 4. So x square is going to be 12. So x is going to be root 12. They mentioned it as root alpha. So what is the alpha value? It's 12. That's it, right? Super. Next one. This is 2023 JEE mains. Prasanna Kumar. Hi Prasanna Kumar. Nilin Paul, very good. Yash, very good. Full best. Very good evening and hi Amma. Mr. Prasanna Kumar, we are done with very good basics. But still, yes, if you want, you can do the questions. Velocity of the particle executing SHM varies with the displacement as. Simple. Time period of oscillation is x by 7. See, if you want to get the time period, you need the omega. So if I am going to talk about v square, I can write it as 1 by 4 into 50 minus x square. Then v can be written as what? Half under root of 50 minus x square. Compare this with v is equal to omega under root of a square minus x square. Omega under root of a square minus x square. When you do the comparison, you get omega as half. Then what will be the time period, sir? Time period is 2 pi by omega. So 2 pi by half, which is going to be how much? 4 pi. Which is going to be how much? 4 pi. That is it. And they are requesting you to put it as, put the pi as 22 by 7. You get 88. Okay. Particle of mass 250 grams executes a simple harmonic motion under a periodic force of minus 25x. Particle attains maximum speed of 4 meters per second during its oscillation, and they are expecting you to calculate the amplitude. Look, whenever you are going to come across f is equal to minus 25x, so you have to compare it with what? Kx. So from here k is going to be how much? 25. And one more thing which they have mentioned is that a omega is how much? 4. And they are asking you amplitude. Omega can be written as root k by m. Did they give the mass? Yep, they have given the mass. Mass is 250 grams, which is going to be 0.25 kg. So, a root k, k is 25, which is going to be divided by 0.25, which will be 100 times, is going to be 4. So, a root 100 is 4. So, a is 4 by 10, which is going to come out to be how much? 0.4 meters, can be written as 40 centimeters. The curious cortex is asking, will the paper level be the same? Mostly. But I feel that won't be too easy, will be slightly moderate, not too difficult also. Not like 2020, 2021. I feel it will be somewhere in between 2022 and 2023. Take this as your homework, man. So many questions. We repeatedly do the same thing. You can take this as your homework 2021. If it is 2021, 2022, 2020, they are all good questions. They are all good questions. A particle executes simple harmonic motion represented by the displacement function. You just go through the question, right? You take this as your homework. This is JEE Advanced, or you can say IIT JEE 2009 question. Try this one. Pratigulla Lakshmana Rao is saying that, sir, what about 2026 paper? Man, too early to comment, man. Too early to comment. Better as it is 2026. That means you are in 11th. So you better concentrate on learning rather than worried about how the paper is going to be. See, I always believe in one thing. Always worry about the things which are there in your hand. Don't worry about the things which are not in your hand. For example, will the NTA set the paper easy or difficult? Is it in your hands? Even thinking about whether the paper will be easy or difficult even for a second also is going to be waste for you. Aerospace IITN, Aeroaspire IITN, weightage of this chapter is one question in JEE Mains and one question in JEE Advanced. XT graph of a particle undergoing simple harmonic motion is shown below. The acceleration of the particle at t is equal to 4 by 3. Man, one thing, you just look. Here to here, what is it? 4. That means if you talk about exactly the center, it's 2 seconds. So that means to go from x is equal to 0 to the extreme. How much is the extreme? Extreme is 1. Extreme is 1. That means amplitude is 1. How much is the time period? Time period is 8. Because you can see the very same motion is repeating after 8 seconds. So the time period of this particular SHM is 8. Okay. Now look what they are asking at 4 by 3 seconds. Okay. Sure, we can do that. I can write x is equal to a sin omega t plus phi at time t is equal to 0. What is the x value? 0. That means a sin phi should come out to be what? 0. So the phi value can be 0 degrees, pi degrees and so on. Which one you have to pick? See, if I am going to take this as pi, then A sin omega t plus pi will come, right? So as omega t increases, the value will go beyond 180 degrees. What is the sign beyond 180 degrees? Negative. But how is the displacement as time increases? As time increases, displacement is positive. That means I have to pick 0. So that means it's x is equal to A sin omega t. A is how much? 1 sin omega t, and for your kind information, time period is how much? 8 seconds. So 2 pi by omega is 8. So omega is going to be pi by 4. Just keep that in mind. Just keep that in mind. Okay. Now what is veda then? It is omega cos omega t. What is acceleration? Again differentiate this one. You are going to get minus omega square sin omega t. For your kind information, omega is pi by 4. Sin, what is the omega? Pi by 4. What is the time? Time is 4 by 3 seconds. So 4 and 4 gets cancelled out, you get sin 60. Sin 60 is what? Root 3 by 2. So you get minus root 3 pi square by 32. Minus root 3 pi square by 32. So which option? Option D. Now look. Let us go a bit deep. Now I am going to make you dive a bit deep. So whatever I am going to do now is you can say for JEE Advanced rather than for JEE Mains. Is going to be JEE Advanced rather than JEE Mains. We will talk about the position and time analysis, right? First, I'll start with the mains part. The next I'll do some questions of the mains part, and then as I said, we will dig more deep into this one. Look man, for you to understand, what I'll do is, I will take an SHM which is going to be A sin omega t. So at time t is equal to 0, what is the position? At time t is equal to 0, its position is going to be what? X is equal to 0. That means whatever the particle I talk about is starting at the mean position. Now, I won't say starting at the mean position. At time t is equal to 0, the particle is at mean position. There is a reason why I changed my statement. There is a reason why I have changed my statement. Okay. Now look, I want to know in how much time the particle is going to go from here to x is equal to a by 2. Let me just mark that. Let me just mark that. Most of the people get this thing wrong. This analysis should be there on your fingertips. And me, after giving this analysis, will be helping you a lot in actually visualizing the things even better. Most of the people's misunderstanding will be cleared here. Now this part whatever I am doing is going to be for both advanced as well as mains. Later slightly might be after doing some questions on this I will dig deeper, then you will get it. Okay fine. I want to know at what times it is going to be at a by 2. So as I have chosen this, I will put x as a by 2 is going to be a sin omega t. Ding. The sin omega t should be 1 by 2. Now the thing is, for what angles sin is going to be, sorry Amma, sorry, it is minus a by 2 Nana. Sorry. For what angle sin is going to be 1 by 2? For 30 degrees. And then next 150 degrees. And then next 390 degrees. and so on. So if I put them properly, 30 is pi by 6, right? And this is 5 pi by 6, right? And this is 13 pi by 6, right? And so on. So I'll talk about the times at which what I'll do is I'll multiply 2, I'll divide 2 for all of them. So if I'm going to be multiplying 2 and dividing 2, then I'll get a situation like this: 2 pi by 12 omega 2 pi into 5 by 12 omega, like this you are going to get 2 pi into 13 by 12 omega. So 2 pi by omega can be written as what? Capital T. So capital T by 12, 5t by 12, and then 13t by 12. So I will not bother about these times because those times are more than one time period. And it makes sense also why it is coming out to be more than one time period. But before we go for that, the first time at which it is going to be here is t by 12. So when you look at the movement of this one, it goes, it returns, goes, returns. So in one oscillation, how many times the particle will be crossing x is equal to plus a by 2 means it will be crossing 2 times. Yes, Hitman, this lecture is enough for JEE Advanced. I'll go deep. But you have to take questions. You have to take questions, previous year's questions and all those things, and you have to do. No, I will be in Vedanta Telugu JEE. I will be there on both the channels. I will be there in both the channels. Okay. So to go from here till here, how much time it took? T by 12. And for your kind information, what is the total time it has taken to go till here? That time has come out to be 5t by 12. So again, after one capital T plus t by 2, again the particle will be here. So in every oscillation, it will be crossing the particle 2 times. One, when it is moving away from the mean position, mark my words, I'm going to use these things. One, when it is moving towards the mean position. I want to know at what time it is going to be at x is equal to a. Let's find that. We know that we have taken x is equal to sine omega t. So that I'll put this. So the sine omega t should be what? 1. Sine omega t should be what? 1. So the omega t for what values? For pi by 2, for 5 pi by 2, and so on. So when I am going to talk about it is pi by 2 omega, 5 pi by 2 omega, and so on. So when you talk about these times, first is t by 4. All I have to do is just multiply 2, divide 2. Then it will become 2 pi by omega by 4, which will be t by 4. It's enough, Mr. Curious Cortex, the Curious Cortex. Yes, it's enough. Okay, if you look at, see, this is more than one time period, indicating there is only one time at which the particle will reach x is equal to a in one oscillation. That's obvious. When the particle is going like this, it will touch this extreme only once by the time it completes one oscillation. And that time came out to be how much? That time came out to be t by 4. Now one interesting observation. Now one interesting observation. What is that interesting observation? Yes, Yashna is asking a question, sir, is it same for cos? Always keep in mind, whether it is sine or cos, ultimately you are going to get the same motion. I'll explain when it will be sine, when it will be cos, I will explain to you. Don't worry. I'm going to come to that. That's actually deep, like digging bit deep. I'll come to that. But as of now, to travel first a by 2 distance, it takes t by 12 time. And to travel a distance, it takes t by 4 time. Do you know one common mistake what people do? They know that this is t by 4, this is t by 4, here to here t by 4, here to here t by 4. So they take that as it takes t by 4 time to travel a distance. To travel a by 2 distance, people think that it will be t by 8. But did we get it to be t by 8? Nah, we didn't get it to be t by 8. And in fact, what we got? T by 12. Now I am interested in checking how much time it takes to travel from a by 2 to a, which will be what? T by 4 is the total time to go from here to here. Minus this gives me this, which is how much? T by 6, sir. First half of the distance, t by 12 time. Second half of the distance, t by 6 time. A very important result. Now you might have a doubt, sir, why is it taking more time to travel the second half of the distance? You know that the particle will slow down. Particle is moving faster at the mean position. So the speed will be fast over here and the speed will be slow over here. As a result, what will happen? The speed is going to get, the time is going to get increased for same distance. That's the most important observation. So all these observations, I'll put it into one graph or one diagram. And this, you make sure that you are going to write it somewhere such that you will never ever forget these things. So this, you take it to be x is equal to a by 2. So man, to go from here to here, the time it takes is t by 12. To go from here to here, the time it takes is t by 6. To go from here to here, that is here to here, it takes t by 6. I am saving time. You people can do math and verify for the same thing. Again, to go from mean position to this one, t by 12. Always keep in mind, closer to the mean position, the particle will go. Arey Mr. Arjun, what are you doing, man? Okay. When the particle is closer to the mean position, at the mean position, you will have speeds to be greater, so it takes less time. And have you observed, from the mean position, whether it is to the right side or it is to the left side, the first half of the distance, it is traveling with the same amount of time, in the same amount of time. And this is t by 6. This is again t by 6. And this is again t by 12. Now, if I am going to talk about the phase, the phase here is 0. And tell me when it is going to be, it is pi by 2. And again, when this is going to take place, like when it is going to be at the mean position at pi, you only look, x is equal to a sin omega t. When omega t is 0 here, when omega t is pi by 2 here, when omega t is going to be pi here, when omega t is going to be 3 pi by 2 at negative extreme. This is going to be helping you a lot. Now again it goes and it is going to become 2 pi. Now look man, I am giving you an important observation. When the particle is onto the positive side of the mean position and going away from the mean position, then we are talking about this movement, right? And if you look at that movement, how is the angle, how is the phase? The The phase angle is in the first quadrant. The phase angle is in the first quadrant. Now, when the particle is going, when it is onto the right side of the mean position, but going towards the mean position, this whole journey is towards the mean position. How is the phase? Can I say that it is in the second quadrant? Next, when it is going away from the mean position and being onto the negative side, then what is it? Third quadrant, angle between pi and 3 pi by 2. And when it is onto the negative side of the mean position, from the mean position and going towards the mean position, then the phase you are talking about should be in which quadrant? Fourth quadrant. This will help you a lot. This will help you a lot. So the session is going to be till 11 or something. Till the content is going to get over. I'm in which slide? Let me just check. I'm on 22nd slide and there are around 50 slides. Look, particle going like this journey onto the positive side from the mean position and going away from the mean position, phase angle should be always chosen in the first quadrant. A very important thing which is going to clear a lot of confusions. I am going to talk about that. Okay, I'll give a break. Just wait. So when the particle goes to the right side, the phase is going to be between 0 to pi by 2, and then pi by 2 to pi when it is going to be going to this side, and then pi to 3 pi by 2 when it is going to go this side, and 3 pi by 2 2 pi when it is going to go this side. Okay. Do these questions. After this question, I'll give some 5 to 10 minutes of break. After this question, I'll give a break of 5 to 10 minutes. A simple harmonic oscillator has an amplitude A and time period 6 pi seconds. Assuming the oscillation starts from the mean position, the time required by it to travel from x is equal to a to x is equal to root 3a by 2. So now they are not talking about a by 2, but instead they are talking about root 3a by 2. Right? So let us find that. First let us find, they said that it is going to start from the mean position. If it is going to be from the mean position, you can write it as a sin omega t, because when you put t is equal to 0, you will get x is equal to 0. Hi Likith. Now let us find out at what point of times you will have x to be root 3a by 2. A and a are going to get cancelled out. Then the sin omega t is root 3a by 2. Root 3 by 2. For 60 degrees it will happen. Again for 120 degrees it will happen. So that's the problem. So which phase you have to select? Is it 60 or is it 120? That's going to be a problem, na? So that's why the trick, whatever I have given you, will help. Which phase you have to select. If it is going to be a situation where it is going to be traveling from root 3a by 2 to a, you are talking about this motion. But here they are talking about a to root 3a by 2. That means they are talking about this motion. That means the phase we have to choose is going to be what? 120. The phase we have to choose is going to be what? 120. Thank you, Mr. Likith. I am putting efforts. It's just matter of time for people to realize how good quality is being provided. The dynamics of, to be honest, the dynamics of YouTube has changed a lot, man. See, some time back, people used to think that a person, whoever is going to be capable of facing the camera and even mediocre with the content, right, will be able to manage. But now it is because of you people. Every edtech company has changed their opinion. No, we don't want people who can manage. We want people who can deliver subject rather than acting. See, if you look at me, I am not jumping around, I am not dancing, I am not singing, I won't do that also. I am someone who has come to this platform to seriously teach students. And if you feel demotivated, I should pull up your morale. I should motivate you people. So all those things I can do. Just to, I can just sing, man. That's not me. A teacher is not here to entertain you. A teacher is here to make you learn stuff. That's one good thing. So I have been giving good content, but the thing is, that was being given in Telugu channel. Now I'll be giving the same thing even in English. Okay, fine. And you will find quality teachers over the years. Trust me, you will find lot of quality teachers being on YouTube. The good days are going to start. There are those days. I have been in offline, and I hope majority of you know where I worked. I worked in Allen, one of the best offline coaching institute. I worked in Allen for 7 years. 2017, 2024. I have seen top ranks being produced by the students whoever are taught by me, or I have seen the best ranks come from the Allen system itself. So if you look at any of these offline things, one biggest problem is going to be if you miss one class, done. You won't be in sync with the teacher, you lose sync or the frequency with the teacher. It's very hard for you to come back onto the track. Now you have a lot of online platforms, and majority of the platforms are giving you quality content. As a result, even if you miss one class, you will see the video from online. That's it, done. You learn. Bharadwaj. Okay, fine. Now look what's happening over here. From this mean position, it goes, it comes. So when it is going to go, it will be crossing that x is equal to root 3a by 2. It will cross that x is equal to root 3a by 2. How many times? 2 times. One going this side, one going this side. And I need this one. I need this one. Why? They are asking you to go for the time between x is equal to a to this. That means they are asking this time. So I need to get the total time. That means as I am talking about this whole thing, now the particle is here moving like this. I should choose an angle which is going to be in the second quadrant. Which one is in the second quadrant? 120. So omega t is 2 pi by 3. So the t value is 2 pi by 3 omega, which is t by 3. So nice, good. This whole time is t by 3, sir. And what is the time to go from here to here? It's t by 4. So the whole time t by 3 minus t by 4, which is going to be what? T by 12. Yes, it's t by 12. Mark it. Capital T by 12. They gave the time period to be 6 pi. So 6 pi divided by 12, which will be pi by 2. Just mark 2. According to me, this question is better than what I have done. Like what I have done previously. Better than what I have done previously. Take one more question. A particle executes simple harmonic motion. Its amplitude is 8 centimeter and time period is 6 seconds. Okay. Time it will take to travel from its position of maximum displacement to the corresponding to half of its amplitude. From where to where? Ma, they are asking you to calculate from x is equal to plus a to x is equal to a by 2. They are asking this time. They are asking this time. And what is that time? It's t by 6. And what is the time period? Time period is 6 seconds. So 6 by 6, which is going to be 1 second. 2022. Sandeep, sir, how you are doing videos at a time in Vedanta, Telugu and English? No man, I am not doing at a time. I did semiconductors class from 5:30 to 7 over there and I am doing from 8 over here. So I am not doing at the same time. Do this and then, as I said, I'll start digging deep and I'll prove whether you take sin omega t plus phi or cos omega t plus phi, whatever it is, you'll get the same answer. I'll dig deep. After this, I'll start digging deep. Lokeshwar. Rakesh, love from TN. I have a lot of respect towards Tamil Nadu, man. Rich culture. Yes, I'll take care. I'll see. Okay. A particle performs simple harmonic motion with a period of 2 seconds. The time taken by the particle to cover a displacement equal to half of its amplitude from the mean position. Now they are not asking from extreme, from mean position they are asking. Look at how many times they have asked, man. 2021 they have asked, na? And look at this, 2022 they have asked, right? And then look at this, 2024 they have asked, right? So look at how many times the same concept is being touched. And in fact, I got fed up to pick these questions, these models were repetitive. That's why I said this is very, very useful. Okay, just a second, just 10-15 minutes, like, sorry, this is the last question. You can take break. Yes, na, just 10 minutes, sorry, not 10 minutes, last question, then I'll give 5 to 10 minutes break. A particle performs simple, mean position, from the mean position, it should go to x is equal to a by 2. Okay, nice, good. And we already know how much time it takes. It takes capital T by 12 and the next half of the distance it will take in T by 6. So x is equal to a. Super, good. They asked you to get this and they gave the time period as 2. So it is 2 by 12, which is 1 by 6 seconds. So a value is 6. Okay, fine. I'm giving break. Please take break. Right? Now it's 9:43, right? 9:50 I'll start. 9:50 I'll start. Take 5 minutes break. It's going to be too difficult for you people also, obviously. From morning you would have been to school and then you have come, you might be listening to other classes also. So obviously it's very tiresome. I'll 9:44, right? So I'll give around 10 minutes of break. Let's take 9:54 I'll be back. 9:54 I'll be back. back. Hope everyone had lunch. Sorry, not lunch, dinner. Ashwin, I don't know which crash course you're talking about. So you better just go through the launch. They would have explained everything. Or I'll answer you tomorrow. I'll get the info and I'll answer you tomorrow, man. Yes, na. Sir, I'm very sorry for asking it now. I'm a JEE dropper and I had joined an online coaching. I haven't said anything yet. But I have a bit of confidence within me. Can you say something? It's never late, man. You can always start. It's never late. And especially as far as JEE mains is concerned, in 3 months of time, you can get 99%. It's not a big deal. Ashwin, I'll confirm you tomorrow, man. Ashwin, I'll confirm you tomorrow. So, sometimes you need to write the equations of SHM. They will give a diagram and they will ask you they'll ask you questions where these things are going to meet and all that stuff. So there will be many things which are going to be asked. All those things have been properly segregated and has been put into slides, right? So let us talk about this, how to write the equation of SHMs from the given data. For example, they say that this is the mean position and we have a particle which is at x is equal to, or you can say it is at root 3a by 2 and it is moving towards the right side. They'll ask you, and this is the situation at time t is equal to 0, man. This is the situation at time t is equal to 0. And they'll ask you what is the equation which is going to be representing this SHM. Okay, now you look, it is starting at root 3a by 2, good. So when it is going to be at some random location, you just take that, come on, some a sine omega t plus phi. So at time t is equal to 0, x is root 3a by 2. So put that. So sine phi is going to be what? Root 3 by 2. So what phi I have to choose? Is it 60 or is it 120 or is it something else? So these kind of things will be exactly answered by the data which I gave to you people. So when you are going to be choosing a phase, if it is onto the positive side and moving away from the mean position, your phase should be in the first quadrant. That means the angle should be between 0 and 90 degrees. That means what you have to choose? You have to choose phi as what? 60. So then the equation of this SHM is a sine omega t plus 60, which is this. So like this, when they are going to give you data, you should be able to write the expression or the equation for it. So I'll check to what extent you have understood. It is not mandatory that always they have to give a particle onto the positive side, right? What if they give it onto the negative side? For example, at time t is equal to 0, the particle is at x is equal to minus a by 2 and it is moving away from the mean position. Then what is the equation of this particular SHM? Equation of this particular SHM, any SHM, you can write it with x is equal to a sine omega t plus phi. Put x as minus a by 2. Sine phi. Why? You have to put t as 0. Then the sine phi value is going to be minus 1 by 2, man. So what are the phi values for which sine phi is going to be minus 1 by 2 means 210 degrees. And then 330 degrees. And so on. Now, I don't know whether I have to choose 210 or I have to choose 330. And I always said to you, memorize from the mean position. If it is onto the left side and if it is going away, then it is third quadrant. Then it turns back fourth quadrant. So going away means third quadrant. Third quadrant means angle between 180 and 270. So the equation of this particular SHM is x is equal to a sine omega t plus 210 degrees. Rishyandar Kota is asking a question, sir. Are you going to teach in English also? Yes, I teach in English also. Okay, man. Take this question. Figure shows displacement time graph of a particle executing SHM if the time period of oscillation is 2 seconds. Look, till now what I have given to you is direct representation. Can you see the direct representation? I gave you the mean position and I gave you where the particle is and how the particle is moving. I gave you everything. Here you have to just use your brains to identify whether you have to put 210 or whether you have to put 330. Right? For that I gave a shortcut. Now you look, nothing is mentioned. From graph you have to read it out. From graph you have to read it out. From graph you have to read it out. Now just look at it. At the time t is equal to 0, it is starting at 5 and somewhere over here it is reaching 10 and 10 is the amplitude, Sirji. From 5 it is going to 10 and that too it is onto the positive side. That you put it back into the simple representation. So if this is the mean position, at t is equal to 0, the particle is at x is equal to 5 and it is moving to this side. Maximum it can go up to where? X is equal to 10. So the amplitude of it is 10. So it is onto the right side of the mean position and moving away from the mean position. That means phase should be in first quadrant. So any SHM, what did I give you? Any SHM you can write it as a sine omega t plus phi. So x is what? Half, right? Amplitude is 10 and it is at 5. So it's a by 2. And at time t is equal to 0. So the sine phi value is going to be what? Half. So for what values of phi, sine phi will be half means it's going to be 30 degrees. And it is going to be 150 degrees and so on. Which one I have to choose? As it is onto the positive side, moving away from the mean position, it will be in the first quadrant. If it is towards the mean position, second quadrant. If it is onto the negative side and going away from the mean position, then third quadrant. If it is on the negative side and moving towards the mean position, then it is going to be fourth quadrant. So directly and simply, I can write x as a sine omega t plus 30, which is going to be what? Pi by 6. It makes sense also, man. You can think in one more way. Look, as time increases, omega t value increases. That means the total angle from 30, it will become 45, then 60, then it will become 90. That means the x value should increase. Is the x value increasing? Yes. Mr. Hari Bhaskar, we have this series going on. You can watch this roar series, whatever has been, whatever is there. I think from past 3-4 months they have started it. Either you can use this, or if you are going to be from Telugu background, then in Vedanta Telugu JEE also we have some courses which have been launched. You can watch those videos and solve questions. It's never late. 3 to 4 months is more than enough. Yes, Mr. Yash, but I am trying to keep things simple. Do this question. Do this question. Look, two bodies performing SHM have same amplitude and frequency. Their phases at a certain instant are shown in the figure. The phase difference between them. Be careful. Here you have a particle going away from the mean position, and they gave this distance as 0.5 a. That means this distance is also going to be what? A by 2. So the first one is at a by 2. Yes, Mr. Haribhaskar. Okay, now look. Let us talk about the first one. When I am going to talk about the first one, right, you have the mean position, and that thing is at a by 2 and it is moving to the right side. They only mentioned it. They have put an arrow. It is moving to the right side. Just now we did it, na? A sin omega t plus pi by 6. So, the expression of this is going to be given by a sin omega t plus pi by 6. Okay. Now look, let us look at this one. And that one, if you look at, oh shit, we don't have space. So if we talk about the second one is at x is equal to minus a by 2 from the mean position, and it is moving towards the mean position. At 210 degrees and 330 degrees, it is going to be minus a by 2, right? So I have, it's something which is moving towards the mean position. That means from negative side moving towards mean position is fourth quadrant. So the x for this is a sin omega t plus 330. That's it, man. They are asking phase difference. 330 minus pi by 6 months, that means 30. So 330 minus 30 will be how much? 300. 330 minus 30 is going to be how much? 300. Where is 300, sir? Yep. 5 pi by 3. 5 pi by 3. Okay. Now look. Representation of circular motion as SHM or representation of SHM as circular motion. Anything is fine. Look, let me talk about uniform circular motion. I have an animation coming in the next slide to make you feel it. To make you feel, I have an animation in the next slide. Uniform circular motion. What I will do is, I will choose this as my origin, 0, 0, and this is my x-axis, this is my y-axis. I am just taking it, and I have a particle which is here, and it is moving with some constant angular velocity omega. So what will happen as the time goes on? As the time goes on, this is at time t is equal to 0, sir. So at some time t, the particle is going to be over here at how much angle? At an angle theta. What will be its x coordinate and y coordinate? Let us talk about that. Man, this is going to have its x coordinate and y coordinate. What is this one? This one is going to be the y coordinate. What will be this one? This is going to be the x coordinate. And let us take the radius of this circular thingy to be some capital R. Now what is that? We got a triangle. Okay, let us see that. We have this to be R, we have this to be theta, we have this to be X, and we have this to be Y. What is cos theta? The cos theta value is X by R. And what is the sin theta? The sin theta value is Y by R. So I can write X as R cos theta and I can write Y as R sin theta. Sir, what is so interesting with these things? These are nothing, these are not a big deal. What's the big thing with this? That only I am going to come across. Man, it's uniform circular motion. Can you relate theta, omega and t? Yep. Theta is going to be omega t plus half alpha t square. For your kind information, as it is uniform circular motion, alpha is 0. So the theta is going to be what? Omega t. Put it. So then these things will be what? X is equal to R cos omega t and Y is equal to R sin omega t. Is there anything interesting with this? Yes. X coordinate is executing SHM. Of how much amplitude? R. Of how much angular frequency? Same as the angular velocity of circular motion. Same as the angular velocity of circular motion. So, if there is a particle which is executing circular motion, its X coordinate and Y coordinate are going to be executing SHM, where the amplitude of the SHM is R and where the angular frequency of SHM is same as the angular velocity of the circular motion. So from next time, I will do the reverse. If there is an SHM, I will convert it into circular motion. Do you want to feel how exactly these X and Y coordinates are executing SHM? I will show you. Ding. This is how. Take one at a time. It's hard. You look at this. This is performing circular motion and you just look at only this movement. If you look at the particles, only this movement, it is nothing but this movement. Can you notice that? X is even better represented. I found a better animation. Can you see? There is a particle executing circular motion. See the X coordinate, dude. See the X coordinate. So the X coordinate is executing SHM, right? Can you see the to and fro motion? But only thing is that angular frequency of that SHM should be equal to angular velocity of the circular motion. Majority of the times we convert SHM to circular motion. Majority of the times we convert SHM to circular motion. Just keep that in mind. I hope everyone are clear till here. Yes. Use of the representation. A particle executes SHM along a straight line with mean position at x is equal to 0. Period is 20 seconds and amplitude is 5 centimeter. Okay. Time period they gave, amplitude they gave. The shortest time taken by the particle to go from x is equal to 4 to x is equal to minus 3. So if you are going to be writing it in the normal SHM equation, the calculation is going to be slightly difficult. Slightly. But if you represent it in the form of circular motion, man, trust me, it's going to be the most easiest. Easily you will get it. Look at this. So this SHM can be represented like this, right? Okay, that is what I am going to apply. Amplitude is 5. So the radius of the circle should be how much? The radius of the circle should be how much? 5, sir. Okay. Now, what are they asking? They are asking that shortest time taken by the particle to go from x is equal to 4 to x is equal to minus 3. Okay, where will be x is equal to 4? See, x is equal to 4 is going to take place at two positions of the particle, man. Those are these two positions. And when you represent the particle to be performing circular motion, obviously it will have some angular velocity. Let us take that angular velocity omega. So either the particle is going to be at this location. Okay. What will be that angle, sir? This is disturbing us. Let us take this out. Let us take that angle, sir. Okay, da. This is 5 and we know that this is 4. If I take this angle to be theta, what is that theta? The cos theta value is 4 by 5. That means theta is 37 degrees. It's 37 degrees. Okay. So why did I calculate this angle? Why didn't I calculate this? Because our aim is to make this one reach -3 in shortest time. This is 5. And how much is this one? This is -3. If I want this angle, I'll take it as alpha. Right? What is cos alpha? Cos alpha, I just want the magnitude of it. I'll just put it as 3 by 5. So the alpha is 53 degrees. So particle traveling from x is equal to 4 to x is equal to -3, there are two situations. The particle might have started here and traveled all of this. That is one case. The second case is the particle has traveled from here to here. In which situation you will get less amount of time? Obviously from here to here. Obviously from here to here rather than this. So when they say x is equal to 4, there are two possibilities. Particle can be here or here, but they are shortest time. You have to take the particle to be here and it should go like this. Now you tell me, if this is going to be 37 degrees and if this is going to be 53 degrees, what is 53 plus 37? 90. Then what is this angle? This angle should also be 90. So how much angle it has to cover, sir? 90 degrees angle it has to cover. So to cover 360 degrees, how much time it takes? To cover 360 degrees, it takes one time period. Then to cover 90 degrees, how much time it takes? So the question mark into 360 cross multiplied. This into this is going to be 90 into capital T. So this is going to be 4. So the time it takes is going to be T by 4. What is the time period? 20 seconds. So 20 by 4 will be how much? 5. Good evening, Jitesh. Okay, Hemang. Hey, Hemang, Harshit. These are my Alan students. What, Hemang, you see these videos also? Okay, now let us talk about least time for two SHMs to meet. Like what kind of questions are going to be given? What kind of questions are going to be given? For example, there will be two SHMs having this is the mean position, man. One is at x is equal to a by 2 and traveling towards this side. And the other one is at, for easier calculations I am giving this, is at x is equal to minus a by 2 and traveling towards this side. Both of them, both the SHMs have same amplitude and the time period. That means omega is also same. Okay. Now let us talk about this. There are two ways to do it. You can find the position of this one as a function of time. You can find the position of this one as a function of time. When both of them are going to be meeting, they are going to be at the same location. So what I want from this question is find the minimum time in which they meet. Find the minimum time in which they are going to meet. Okay. Writing equations and equating them is going to be a difficult process. Writing equations and solving them is going to be a difficult process. That's why we represent things in the circular motion. Now look, for simplicity, I will change the colors. This is the particle. One is yellow particle, one is green particle. As I said, SHM can be represented as circular motion, right? They have same amplitude. That means the radius of the circular path should be what? Same. I'm going slightly deeper, slightly deeper, not too difficult and at the same time not too easy. But yes, this representation is going to help you out. Fine. What is that? Where is the green particle? The green particle is here. At how much x? At an x of a by 2. And this is a. Can you get me this angle? Yes. That angle will be 60. I am saving time. Okay. Some people might struggle. I'll just take it as alpha. Now you tell me what is cos alpha from here. Cos alpha is going to be a by 2 by a, which is going to be what? 1 by 2. So the alpha value is going to be 60. This is 60. And now it is very challenging for us to decide in which direction that is performing circular motion. Is it going anti-clockwise or is it going clockwise? That we get it from here. Can you see how is this particle moving? This particle is moving in this way such that the x coordinate decreases. So this particle should go in this way such that the x coordinate decreases. If it goes like this, the x coordinate decreases. So how is this moving? This one is moving with angular velocity omega to the left side. Okay. Now let us talk about this yellow one. So the yellow one is at how much x? It is at minus a by 2. This is what? A. Let me just take this angle to be beta. I want just the magnitude of that beta. So what is cos beta from here? Cos beta is going to be I just need the magnitude, man. So this is also half. That means the beta over here is going to be how much? 60. 60. Then what will happen? You look at this. If this is 60, then this should also be what? 60 degrees. And one more thing, we have to decide the direction of movement of this particle, right? How is it moving? It is moving in such a way that it has to go closer to x is equal to 0. So it has to go closer to x is equal to 0. So how this moves? It moves like this. So both these particles, when they meet, they would have covered how much angle? They would have covered 60 degrees angle, right? So the angle covered by this one, together should be 60, then they meet. I'll show you that. So when they are going to be meeting, for sure, when they meet, both of them together should have covered how much angle? This is going to cover some theta 1 angle, this is going to cover some theta 2 angle. If they meet, then that theta 1 plus theta 2 should be equal to 60 degrees. Then only they are going to meet. I am from Andhra, Mr. Prajit. So what is that theta 1? Omega t. What is that theta 2? Omega t. Why did I say only omega t? Because we are talking about a uniform circular motion. And there is no alpha, that's why the theta can be written as omega t. Okay, done. What is the time? It's pi by, this is pi by 3 man, and you have 2 omega, so you will get pi by 6 omega. So I will multiply 2, I will divide 2, as a result 2 pi by 12 omega, and this can be written as 1 time period, so it is time period by 12. Easily we got it, right, without writing any expressions. Easily we got it without writing any expressions. Around 11, Mr. Rakesh. Around 11. Around 11, Mr. Rakesh. So the T is going to be capital T by 12. Array, mostly. Okay. So this question is a very good question. I am giving this as your homework. And one more thing is that representing like circular motion is going to be very, very difficult over here, because both the SHMs doesn't have their mean position as same. Both of them don't have their mean position as same. They are going to be different. So here you better do it with equations only. But still, it's a very difficult question, although it is 2011 AAEE question, but it's a good question. It's a very good question. So take this as your homework. Take this as your homework. Now look. After this, we are going to do superposition. We will do energy in 15-20 minutes, and then we are going to start with the superposition of SHM. That's the part where things are going to be a bit more interesting. Superposition, that's where the phasor diagram kicks in. So I will properly explain why the phasor diagram has come. I will properly explain why the phasor diagram has come and all those things. Okay, fine. Energy associated with SHM, sir. Already by now work power energy has been completed to you. Right? Okay. One thing. First, I will talk about kinetic energy, because this is the most easiest to deal with. Half mv square, where m is the mass of the particle executing SHM. How about v? And one more thing is that we can put v in terms of time also. We can put v in terms of x also. In our syllabus, majority, not majority, all the time we are going to be interested in position relation only rather than time relation. So if you remember, for your kind information, the speed of the particle is omega under root of a square minus x square. So half m, what is the v squared? It's omega square into a square minus x square. And that omega square is what? For your kind information, in the beginning of the lecture, omega square was k by m. So let me put into that. So half m into, what is the omega square? K by m into a square minus x square. So m gets cancelled out. So the kinetic energy is going to be half k a square minus x square. So how will be the graph? I will be plotting kinetic energy versus x. And all those people who haven't liked the video, please do like the video. Only if you love the content. If you don't love it, don't like it. But if you feel that what we have done till now is worth, do like the video. That's how the YouTube is going to be promoting the video. Do like the video, that only then the YouTube is going to be promoting the video. So it reaches majority of the people. That's our aim. Okay, fine. Now let us, in this class only, I said to you, our brain will process stuff if only y and x are going to be there. All of a sudden we have kinetic energy. Array, convert it. Whatever is there on the y axis, that you write as y. Whatever is written on the y axis, that you just put it as y. So y, k square by 2 is a constant, minus k by 2 into x square. So this is a form y is equal to ax square plus c, where a is what? Negative. You only see there. You only see that. A is what? Negative. So whenever you have coefficient of x square negative, it's an inverted parabola. If coefficient of x square is positive, it's an upward parabola. If coefficient of x square is negative, then it's a downward parabola. Rakesh. Okay. Rakesh says that he liked the video for the work and the English I speak. Is it that good? Mr. Rakesh? Is it that good? Okay, it's an inverted parabola. And one more thing. This is your x is equal to minus a, and this is your x is equal to plus a, and this is the point where your x is going to be 0. And for your kind information, when x is going to be 0, you have maximum kinetic energy. Obviously, x is going to be maximum. Sorry, if x is going to be 0, at that location speed is maximum. X0 means what? Mean position, na? At mean position, speed is maximum. If speed is maximum, automatically kinetic energy is also maximum, na? That's what we got. And how I have decided that it is an inverted parabola? Whenever you have y is equal to x square plus c terms, and if the coefficient of x square, not only here, everywhere throughout physics, if coefficient of x square is negative, it's a downward parabola. If coefficient of x square is positive, it's an upward parabola. Vivek, which part I have to explain once more, man? You have to be precise, sir. You have to be precise. Just go in the video some 10-20 seconds back. You'll get it. You'll understand it. You should have a basic of this. This is an expression or the equation for parabola. For parabola. If you are going to be, Sam Nishant is asking a question. He is asking that, sir, what is the best thing for mains as well as advanced? Right? To be honest, you buy any previous year's book, 48 years, 49 years, like that will be there, right? Like Disha publications, errorless publications, or you talk about Aryan publications. That's the best way to revise and best book. If you do only those questions, if you complete everything in that book, you will get a rank below 1000 in JEE Advance. Now, if you want to have very good understanding of concepts, Shashi Bhushan Tiwari. Shashi Bhushan Tiwari, there will be only numericals. Level 1, if you do, you will get very good conceptual understanding. Okay, when we are going to talk about a particle executing SHM, do we have only the kinetic energy? No, there is also a force acting on it. So whenever there is a force acting, and what is that force, sir? It's minus kx. Isn't this very similar to spring force? So, if spring is applying kx force and if the spring is storing elastic potential energy, then whoever is applying this force on the particle to make it execute SHM, that should also store some energy, some potential energy. What is the definition? Work done by the conservative force is minus of change in potential energy, sir. This comes from work power energy chapter. Right, I am talking about a mean position. At a mean position, this particle is at a distance x and going in this direction. Let us take that it is going to go in this direction by some dx. Then whatever the force is acting on it, obviously it is acting to this side. So what is the work done by it? The small amount of work done by it is obviously minus k into dx. Why did I put minus? Because, one second, made a mistake. Force into displacement, minus kx into dx. Minus kx into dx. Okay, till here also it is fine. Now, I want total work done. This is the small amount of work which is done to go from x to next dx displacement. But I want the total work from x is equal to 0 to x. Then I'll get the total work done by this force in this x displacement. Okay. Then if you want total work done, you have to integrate. Where to where? I want to calculate from x is equal to 0 till x. So when the block moves from here till here, what is the work done by that force which is trying to bring it back? No, the H.C. Verma is outdated. Don't do. Shashibhushan Tiwari is better. Shashibhushan Tiwari is better. Level 1 of Shashibhushan Tiwari you can do. You'll get very good understanding of concepts. I don't know why it is underrated book, but it's a very good book. Okay, now let us do. K is a constant, take it out. Integral x dx, x square by 2. Okay, you have to put the limit 0 to x. So the work done is coming out to be minus half kx square. That work done by the conservative force is minus of change in potential energy. So minus of change means final. Whatever the potential energy it is going to have at x distance, that I'll write ux. Minus whatever the potential energy it is going to have at mean position, that is 0, u0. Man, the actual potential energy should be written like this, but the books are going to write something else. So the potential energy at x separation is going to be potential energy at the mean position plus this one. But books take potential energy at mean position to be 0. Some good questions test your knowledge on this, whether you know it or not. So the potential energy at x distance is not half x square half kx square all the time. It is u naught plus half kx square. You have to check whether there is potential energy at the mean position or not. Vishnu, no, I will be completing SHM by tomorrow. By tomorrow I will complete SHM. Vishnu, 2 sessions, Amma. 2 sessions. If the potential energy at the mean position is taken 0, then the potential energy at x distance from the mean position is this. I want the potential energy versus x. For your kind information, as I said, our brain is going to be processing stuff. Our brain is going to be processing stuff when the equations are in y and x. So this ux, you put it as y half k x square. Now you look, man, this is like parabola, right? Just look at it. Y is equal to k by 2 into x square is very similar to y is equal to ax square, na? The coefficient of x square is k by 2, which is positive. That means the graph should be an upward parabola. Too good? Good. Now we got the potential energy, we got the kinetic energy. What is the total energy then? The total energy is going to be obviously kinetic energy plus the potential energy. Kinetic energy plus the potential energy. Okay, what is that kinetic energy we got? Half k amplitude square minus x square. Plus what is the potential energy? Half k x square. Add them. Are you getting the total energy of SHM to be half k square? Yes, man. And don't you see that it's a constant? Yes. K is the proportionality constant. A is the amplitude. Even that is also a constant. Amplitude of SHM is constant. So, when the this simulation, look at the energy. Look at the energy. Look at the total energy. Total energy is always constant. Can you see the potential energy to be changing, kinetic energy to be changing? You want to make it, oh, 1 second. Oh, it won't zoom in. Yes, it's getting zoomed in. It's getting zoomed in. You look at that. See, total energy is constant. You look at how potential energy is changing and kinetic energy is changing. So whatever the total energy is there, it is continuously getting exchanged between KE and PE. It is continuously getting exchanged between KE and PE. Look, KE became 0.1. Now the KE is becoming 0 and look at what is happening to PE. It became 0.1. So at one point of time, the whole energy was with kinetic energy. And at one point of time, the whole energy is with potential energy. Okay, nice. Let us go back. So let us put all of them into one. Let us put all of them into one graph. Let us put all of it into one graph. Position. This I will simplify and I will say energy. Right? How was the kinetic energy? The kinetic energy was like this. So this the blue one is the KE. Right? And then if you look at the yellow one is this. The yellow one is the potential energy. Now if I talk about the red one is the total energy, and the total energy is always constant. That's why I have drawn a flat line. And can you see that there is a point where kinetic energy and potential energy are equal, and there is a point where kinetic energy and potential energy are equal. I am interested in finding out that point. So let us find that point. We'll just try to find that point. Potential energy and the kinetic energy have to be same. Potential energy half k x square. Kinetic energy half k a square minus x square. So k by 2 gets cancelled out. So the x square is a square minus x square. So 2x square is a square. So x is plus or minus a by root 2. So at 2 positions, the particle stores equal energy. At x is equal to minus a by root 2 and at x is equal to plus a by root 2. The particle is storing energy, the total energy equally among P as well as K. So let me make you visualize this. Look, you take this to be the mean position, and when the particle is at the mean position, it has maximum speed, and at this location the KE is half KA square and there is no potential energy stored because x is 0. Now when we talk about x is equal to plus a, that is extreme, at extreme the particle we are talking about will come to rest. So what is the kinetic energy it is having? 0. And what is the potential energy? As x is going to be a, kinetic energy, potential energy is half k x square, x is a. So the whole energy is now in the form of potential energy. So here entire energy was in the form of kinetic energy. As the particle moves, kinetic energy decreases and it gets converted to potential energy. Potential energy keeps increasing, and at this point of time there is no kinetic energy. Entire energy is stored in the form of potential energy. That's what will happen as the particle moves. Now again this particle goes like this. Again what will happen? The entire energy will be in the form of kinetic energy. And again when it is going to come to the negative extreme, that is x is equal to minus a, the particle would come to rest. So what has happened? Again the entire energy for this location, the entire energy is in the form of potential energy, no kinetic energy at all. Okay, again it goes and the cycle repeats. And can you understand one small thing? Ke is maximum here. Again for the Ke to become maximum, it's just half cycle. So in half cycle of SHM, kinetic energy has come to the point where it has started. It started with maximum energy, again it came back to maximum energy. So in half cycle of oscillation, kinetic energy completed one complete cycle. Do you agree? In half cycle of oscillation, kinetic energy has come back to the value where it has started. It started with maximum Ke and it came back to maximum Ke. So by the time particle completes one oscillation, kinetic energy completes two oscillations. Every half oscillation, kinetic energy completes one oscillation. Why did I say it is going to complete one oscillation? Because it started with maximum Ke, again it came back to maximum Ke. That means kinetic energy has completed one oscillation because it has come back to the point where it has started. Like the energy started with Ke max. And now again energy is at Ke max. For that to happen, half oscillation has completed. So the frequency of energy oscillations will be double the frequency of SHM. You would write that frequency of energy oscillations, is going to be 2 times the frequency of SHM. 2 times the frequency of SHM. I'll clearly explain why that happens. Just have this in mind. They haven't asked it, but yes, have this in mind. Keep this in mind. Okay, now do this question. It's JEE Mains 2019. See, any questions, any JEE Mains questions before 2023 are decent. Come on, man. We are almost there. Okay, I can feel that saturation. In you people. So I won't strain you much. This is one question. Next is going to be one more. With that, I'll stop the session. Superposition of SHM. So I'll carry forward it to the next session of SHM. So in that next session only, I'll try to complete the whole SHM. Because finding time periods is not going to be a big deal. 2 hours is enough. Like half an hour, I can complete the superposition. I'll teach you properly how the phasor diagram concept has come. I'll properly teach you how the phasor diagram concept has come. Come on, answer. I know you are going to be a bit sleepy. Come on. Let me check how many of them are there in online. Come on. Fast. Super. Oh, Sanjay has answered it. As 3. Sweetie Lucky, hi. Rakesh. So please take care of your I'll do that, man. See, I'll be honest with you. Never in my life I have thought till 11. We are close to 11, man. For the first time. Hey, Mang, arey, you idiot, you are in RBD and you are answering SHM. What, you listen to my entire class or what, Hemang? Idiot. You are in 11th, da. SHM hasn't started for you. This fellow is my old student. When I was in Allen. Joshua John. A by root 2 super. A particle is executing Hey, this I already did, na? Shit. Just now I did it. Just now I did it, da. I was just giving you where the potential energy is equal to the kinetic energy. So potential energy will be equal to the kinetic energy, obviously at plus or minus a by root 2. Okay, do this. This is the last question. This is the last question. A particle undergoing simple harmonic motion has time dependent displacement given by x of t is equal to a sine pi t by 90. Ratio of kinetic energy to the potential energy of the particle at t is equal to 210. It's normal. You just need to know that the potential energy is going to be half k x square and the kinetic energy is half k a square minus x square. Okay. Now we have to get the x value. We get the x value, we get the potential energy, we get the kinetic energy, and we can talk about the ratio what they are talking about. So first get the x value. So when I am going to talk about the x value, it's a sine pi t is how much? 210 divided by 90. Okay. Then 3 3s, 3 7s. So x is going to be a sine 7 pi by 3. A sine 2 pi plus pi by 3. Sine 2 pi plus pi by 3 can be written as sine pi by 3. So a sine pi by 3. Sine pi by 3 is nothing but what? Root 3 by 2. So it is root 3a by 2. Done. We got the x value, man. We got the x value. So once we get the x value, the p is going to be half k. What is x? Root 3a by 2 square, which is going to be 3ka square by 8. Okay. Now let us talk about the k. The k is going to be half k a square minus x square, which is going to be 3a square by 4. So you get k a square by 8. Now what is the ratio they are talking about? The ratio they are talking about is going to be ke by pe, right? Ke by pe. So it's ke by pe ratio they are asking. K is ka square by 8 by p is 3ka square by 8. So this gets cancelled or you get 1 by 3. Yes, 1 by 3. Option 3. Very good, Sanjay. Very good, Sanjay. Are you also my ex-student, Mr. Sanjay? Ex-student from Allen. I feel like you are also. Okay, fine. We will stop here. We will stop here. The superposition part needs lot of your attention. Me doing at this point of time already it's almost 3 hours. Nithila SR, very good Amma, very good, super. Almost it's 3 hours, so you would be saturated. Doing a logical thingy after 3 hours is going to be draining for you. So I'll shift this logical section to the next session of SHM. Meanwhile, you people can do all the previous year's mains questions. Advanced, very rarely kinetics of SHM will be asked, right? Dynamics of SHM only will be generally asked in JEE Advanced, but you will have lot of questions in mains. Do all those questions. Good night. Good night. I'll save this PPT. I'll save it. Right. Will be shared. Sanjay, thank you. Thank you, Sanjay. Rakesh, Vinay Kumar in my experience, go for physics galaxy book if you have time, or otherwise if you have not have time, go for Vedanta Tatva for physics, and for maths engage algebra. Even galaxy is good. Sanjay, easy to understand. Thank you, man. When is the next session? Tomorrow you have the next session, da. Tomorrow you have the next session, but the problem is it won't be on SHM. It will be on modern physics and it will be photoelectric effect. So what they have planned is that first like one class is going to be on 11th topic, one class is going to be on 12th topic, so that you people are going to get enough time to work questions on this 11th topic as well as 12th topic. So the next SHM video will be rolling out next Tuesday night at the same time, 8 to 11. Good night, sir. Thank you so much, sir. Yes. You have one more session tomorrow, but that is going to be modern physics, high scoring one. High scoring one, and we will be talking about photoelectric effect. In fact, dual nature of matter I'll try to complete. Always waiting for tomorrow session. Good, Rakesh. Bye everyone. Bye everyone. Good night. Keep working hard. When I will be doing semiconductors, I'll come in a sequence, man. Once the modern physics is done, I'll do semiconductors. Yes, Suraj, I have covered the advanced, like whatever conceptual clarity you need for advanced, that also have been covered. Conceptual clarity, whatever you need has been covered, although I haven't taken a lot of questions on advanced, but 1 or 2 questions I have taken. Yes, I am famous for that. Even when I was teaching in offline also, I am famous for making things, complicated things, to make people understand complicated things in an easier way. That's what I was famous for when I was working in Alan also. I had huge following there. Fine. Good night.